within the Wind River Range. Not a big deal. Again, it's supposed to be an animation where we fly in and actually see what's going on there. But just mention really quick here that we've been working on the Wind River Range for several years now, conducting quite a bit of research there. And there hasn't been a whole lot of research on the ground within the Wind River Range. There's been a lot of research when it comes to remote sensing, and that's all very good. But you need to really be on the ground to get the full picture as to what's happening with these glaciers and why they are important to everybody, including the biologists. Okay? So, first of all, you might look at them and say, well, only 60 square kilometers, what's the big deal with that? They're not very big. I've heard people say that a lot. I've actually been rejected as far as grants go because, oh, the glaciers are too small. Nobody really cares. That's garbage, in my opinion, because these glaciers are quite substantial. If you think about it, looking even at Knife Point Glacier here, you're looking at potentially up to 60 meters deep. And that doesn't sound like a whole lot, but that's a 20-story building. It's very substantial. These glaciers are quite large, and they're putting off a lot of water. So we really need to be paying attention to them because they are going away fairly quickly. And so somehow we need to be monitoring these things a lot better. But to give you a sense as to what we're doing in the, at least in the Wind River Range over the last several years, I'm going to kind of run through some of the objectives, and which objectives that really should be placed into a glacier monitoring program. So the first thing that we want to do is look at how these glaciers are changing over time. What are their melt rates? And how are those melt rates changing over time? And we can do that through things like using GPS, going actually out onto the glaciers, which is really hard work, by the way, and measuring the surface of the glaciers and comparing them to old topographic maps or radar data, which is collected at various intervals, LiDAR data potentially that may be collected. And so we have essentially a set of data going through time to be able to show us how this glacier is changing, not just in area, but actually in terms of its surface, its elevation. And so if we take a look at Knife Point Glacier, just as one example, you can see all the red up there showing all the melting that's going on. You know, almost well over a meter per year of melting. And of course, all the reds and the yellows are showing melting, and the blues are showing thickening. There's not a whole lot of blue up there, is there? Well, what's the other interesting thing is if we take a look at the 1966 boundary of the glacier, here's 2012, okay? Now, we have data from 2015 as well, so this is from 1966 actually to 1999 as far as the melt rate that you see in color here. And then in 2015, we collected GPS point elevation, which we think can also compare to those other two data sets. And we find that in terms of along that particular profile that I just showed, between 1966 and 1999, there was an average melt rate of about half a meter per year. Between 1999 and 2015, it went up to 1.6 meters per year. So they're going away quick. If we take a quick look at Continental Glacier up on the north, what we see with that, kind of the same thing. Here is a map showing the melt rates of Continental Glacier from 66 to 99. And we see 0.23 meters per year, which doesn't sound like a lot, but over that time period, that's 16 meters of loss. If we take a look at 99 to 2012, this is what we have, 0.37 meters per year. That's an increase of 1.6 times. So these glaciers are melting on a range of 1.6 to 2 to 3 times faster over the last 16 or so years as compared to the last 30, or the previous 33. So the second objective that we have is how much glacial volume is there actually left, because we want to know how much water is actually there as a potential water resource. So we actually go out with an ice-penetrating radar and drag it across the glacier. This is really hard work. And we end up coming up with a bunch of points that, depth points that allow us to create a digital elevation model. And so we can see essentially a bedrock model of the glacier over on the left-hand side and the glacial volume on the right. Basically, Continental Glacier, we come up with a volume, let's put it that way. We come up with an ice volume of 72 million cubic meters. Okay, that might not mean a whole lot to you, but take that entire glacier and melt it out, and it would cover essentially 213 square kilometers in 1 foot of water. That's a lot of water just out of one glacier. So then we can also take the melt rates of the glacier and apply it to the volume and come up with a rough estimate of how long the glacier might be around. Again, this is pretty rough, but it gives us a good ballpark. It gives us a good understanding. Of course, things could change. The climate's obviously going to change over time. These are basically based off of conditions that we see today. And what we find is that the glacier over the next 50 years is going to decrease likely in size by 50%. And over the next 125 years or so, we'll become a remnant glacier with not much left, if things continue the way they are. All right, so the third objective of studying the glaciers then is to look at how much water is actually coming out. This is the stuff that's really important to the biologists out there. And not just the biologists, I would say anybody studying the GYE, because the water really is the lifeblood of the ecosystem, right? So how much water is actually coming out? How is it contributing to the downstream flow? So we actually go up there and get in the freezing cold water and measure this stuff. And we go ahead and put in gauging stations, temporary gauging stations to get at least somewhat of a timeline of the stream flow. And it's coming right off of the glacier, so we know that this is essentially glacial meltwater. So what we end up finding is that you look at something like Bull Lake Creek Watershed, and you look up in the corner where the glaciers actually are. This is a huge watershed. And look at those tiny little nothing glaciers, right? They're nothing. Well, if we zoom in on them, look at them a little bit closer, and think about how much water might be coming off of those based off of our measurements, and we find that those glaciers are actually contributing around 45% to Bull Lake Creek, and around almost 30% to the Wind River nearby. If we take a look at Torrey Creek on the north end of the range, we find that it's actually contributing, that the glaciers are contributing 80% approximately to Torrey Creek stream flow, and about 22% to the Wind River. A little bit smaller glaciers, but still very significant to that particular watershed. So these glaciers are important. They are actually contributing quite a bit of water. There was a study that was done, or I should say some measurements that were done at Mammoth Glacier just this last summer that were showing the same things, where Wells Creek, and might not mean a whole lot to you guys, which dumps into the Green River, coming off of Mammoth Glacier, was way more of a contribution than Green River. So these glaciers are actually substantial, and they need to be looked at, they need to be monitored. Because if you think about it, again, the water is the lifeblood of this ecosystem. And so if we look at what this means as far as the future, not just the ecosystem itself, but humans too. 96% of the surface water in Wyoming goes to irrigation. A lot of this water in the late summer season is, if it's gone, because the snow melts out by the end of July or so we're talking August and September, if the glaciers then are gone too, since they're supplementing that stream flow once the water is gone, or excuse me, once the snow melt is gone, what's going to happen when those glaciers are gone too, and they're no longer supplementing that stream flow? That's a significant issue to irrigation in particular, to drinking water, to fisheries. As far as the ecosystem itself, that's another issue. You think about the aquatic species, you think about the riparian zones, you think about the temperatures of the streams, what kind of an effect that will have. The ecosystem will change in those areas. So what's that going to mean for the future? Well, the one thing about it is, what can we do about it? Of course, glaciers are melting, and we can't really stop it. For the most part, we could try to slow down climate change, but glaciers are going to continue to melt, and especially the way things are going, they very well may melt out over the next 100 years. You might think, 100 years from now, well, guess what? 100 years from now, the amount of time that we're projecting for continental is the same, is actually about the amount of time that Yellowstone has existed as a national park. Think about that. Pretty short period of time. So what are we looking for the future? We have to monitor these things. We have to know what's going on. We have to figure out how, as this water changes and as these glaciers change, and when this water disappears, what's that going to mean for the ecosystem? If we don't monitor them, we're going to be caught off guard in the future. And the biologists are going to really be caught off guard, in my opinion. So with that, I'd have to say that there are a lot of people over the years that I have to thank, and I'll just kind of run through them quick. Of course, Greater Yellowstone Coordinating Committee gets the bold right there. Too many people actually to thank to really sort of mention. So I do appreciate all the help over the years, and with that, I will take questions.
So we have time for a question.
Yeah. Oh, right.
When you, I was also surprised there's no monitoring program. Is there potential to connect with the work going on in Glacier National Park?
There is. We're actually sort of discussing that right now, and the difficulties of the wilderness. One of the reasons why there probably isn't a glacier monitoring program, I shouldn't say probably, big reason why, they're really hard to get to. You need people who are dedicated. And And there's a group right now who are dedicated to go in there and do that. But because of the wilderness regulations, it's hard to do exactly what they're doing with the other benchmark glaciers across the West. However, we're going to try to do our best to sort of standardize that data so that others can compare with what we've got.